Hi guys, welcome back to the channel. I hope you enjoy your Christmas holidays right now. Today we are going to build a very simple data pipeline using Azure Data Factory and Azure Databricks. Azure Data Factory is a code-free ETL tool on Azure. You can build data pipelines using the graphical interface without coding whatsoever. Is it a good ETL tool? Not really. It's good for task orchestration as you can schedule jobs and run jobs in parallel, but in my opinion, as an ETL tool is not very good. It's very clunky, cumbersome, extremely slow and difficult to debug. In our case, we are going to build a data pipeline with 3 steps. The first one would be to copy data from one directory in the data lake, add an extra timestamp column in Data Factory and save the data in another directory in the data lake. The second step is to call a Databricks notebook using Azure Data Factory, and we pass a parameter, the column name as a parameter to Data Factory. Then we create a hash key on the Databricks notebook based on this column and save the data in the data lake in Delta format. The last step would be to create a Hive view in Databricks using SQL statement, and while we are accessing the Delta data we have in the data lake. So we have 3 steps. There is one more step, and that would be to actually access the Hive view using desktop Power BI. Because usually when you have performed, all those transformations and you brought the data in the correct format, then BI developers need to have access to those data and create views and play around with the data. So using Power BI, we are going to connect to Azure Databricks and download the Hive table. Now let's dive into the nitty-gritty. The first thing we need to do is to create a data factory. So we'll go here, create data factory, Azure subscription, use your resource group, the name, data factory, Apple, my name, I think it's and UK South version 2, that's fine. Git configuration, configure Git later. Networking, public endpoint for the time being. Advanced tags, we don't need tags, create and now we are going to create the data factory, and using the data factory we are going to create our data pipeline. So we click here, go to resource, we open the data factory, launch studio, and the first step would be here on the left side on the panel, click this pencil and pipelines, click the 3 dots, create new pipeline. Here we are, and we want to copy data. So click on the move and transform button, expand this and drag this copy data icon here. Copy data, that's fine. So now we have to define the source. The source would be our data lake, and let me go to the data lake under containers. I have 3 containers, and here under my test container I have 3 directories. We are going to copy only the sellers directory. It has those Parquet files. I'm not going to use the rest of the directories because they have a lot of data, and as I mentioned, Data Factory, although it's an ETL tool, it's very slow. It will take ages to copy those data, so I I just copy the smallest table here that we have in Parquet format, and as you can see, under source, we have to create a dataset. We click new, we scroll down to Azure Data Lake Storage Gen 2, continue. That would be Parquet files, continue. And we have to create a new linked service. Now, linked service is the connection between Databricks and the data lake. We click new, and we click select this subscription, authentication. We want service principal, Azure subscription, storage account name, example video 123, credentials, service principal ID, and okay, so the service principal ID, we have to go back to Azure Active Directory to get our service principal ID. We go here, click the service principal, application ID, copy to clipboard, and paste it here. And then from Azure Key Vault, we service principal key, Azure Key Vault, and we have new linked service to the Key Vault. So first of all, we have to create another connection from Data Factory to the Key Vault in order to get the service principal credentials. Select Apostles Key Vault. Here you see it's going to use the Data Factory APO, which is the month identity, which is like a service principal. And here, if we test the connection, let's see what happens. Connection successful. Okay, create, and then secret name. Azure Key Vault 1, secret name. Why doesn't secret name? If we go to Azure Key Vault, we need to get the secret name here. See if that solves the issue. Test connection, secret latest version. Connection failed. Why? Access policy in the key service principal. Okay, fine. So we go here back to the Key Vault, access policies. We need to create, select template, key secret and certificate management. Next, we need to provide to the service principal, actually to the Data Factory first, Data Factory APO, and click next, review, create. So the Data Factory application is going to have access to the Azure Key Vault here and be able to retrieve the secrets we want. So if we click, let's try that again. Connection successful. That's fine. Create. And then back to source dataset. Now we want to specify the file path for our data. Test, and understand we have sellers. Okay, this is fine. We click here, and we need to, let me check the wild path. Okay, test sellers here. That's fine. List while and preview data. Let's see if we can see the seller's data. That means it works correctly, and yes, we can see the data in the preview version, which is great. Here we need to add one more column. Let's call it created underscore DT, and come on, system variables, functions, date functions, UTC now, and yep, that could create an extra column called created date, and that's timestamp, the equivalent of timestamp on Azure Data Factory, and sync. So we loaded the data from this directory. Now sync is where we will place the data, where our target destination. And we need to create another dataset, Azure Data, where is data lake storage, and let's say Parky and link service. The same link service because the connection is the same, but now in this dataset we are going to move the data here. Actually, let me and here sellers. Okay, invalid status error code path not found. Yeah, we have to create the directory first in the data lake. I have done this so many times, but I still don't remember a few things, like when to create directories, sellers. Now let's try again. Okay, that's fine now. Copy behavior, we have options here. None for the time being, but you can see there are many options. Concurrent connections, block size, you can configure those parameters here. The mappings, you can also select, let's say, a column, seller ID, and destination column. That would be something else, just to rename the columns, let's say. But in our case, we don't want that. Or import schemas. Settings, that's fine. Okay, so if we publish that, that would publish everything, our data pipeline, our link services, our datasets. And here under datasets, you will see those two datasets here, right? One to get the data from the source, one to where we are going to store the data. If we click debug here, and we are going to run it right now, as you can see, it's in progress and it succeeded. So you see it ran this step, copy data 1, and here if you click on the glasses, you will see the details of this, let's say, move of the data, this movement of data, data read, files read, rows read, etc., etc. You can see all these cool things here, but let's verify that we have the data here. And yes, we have the data in Parky format, one blob, that's fine. But let's say we don't want the data now. No, actually, let's add the next step, and that would be to use Databricks. And under Databricks, drag the notebook option, and we have to create a link service from Data Factory to Azure Databricks. Select the subscription, Databricks workspace, existing interactive cluster, because we have already created the cluster. Access token, I will tell you how you can do that. So before we move on, I need to open Databricks, right? And here on Databricks, we need to create an access token, launch workspace. You can do that. Let me show you how you can do that. The first one, you go here under you click your account, user settings, and you click generate token, test, and it's going to generate a token. So copy this token because you will not find it again, and paste it on here, access token. Choose from existing clusters. There is only one cluster, and test connection. Great, we have the connection. We click create. Perfect. We have it here, and now we need, under settings, as you can see, you need to specify the notebook path. Let's create a notebook here on Databricks, workspace, users, my username, create notebook, let's say EDW, and I'm going to paste some code here. The first thing we need to do is, let me copy that here and paste it here. So we need to mount the data to create mount points, so we don't, with the data lake, so we don't have to specify the full path every time. And we create a mount point that could point to the test2 container, and one mount point that would point to the test3 container. And that click here, run cell. Yeah, I have to start the cluster first. I forgot it, sorry about that. It will take a little bit. Okay, the cluster is up and running, and we run this command. So we created two mount points, one for pointing to test2 container, one pointing to test3 container. Let me copy the next command, and that would be to actually read data from the data lake. We can do that by using spark.read.parquet, because we have parquet files. The mount point, which is mount slash test2 slash sellers, which is the directory, and here we have the new data frame with this additional column, the created date column, right? This is the one that we added using Data Factory. Now the next step would be to get the parameter from the Data Factory, and that would be using actually that would be, we are going to get a column that we are going to define in the Data Factory pipeline, and we are going to use dbutils.widgets.get hash column. That would be the variable name that we are going to define right now into Data Factory. And here, here, base parameter. Let me first, we need to specify the path, the notebook path, browse, users, username, EDW, and that could be our notebook. And base parameters, expand this, click new, hash column, that would be the parameter name, and the value would be seller ID. That's great. And then if successful, if the first step is successful, then we move to the notebook. So we are going to call this notebook after step 1. That's step 2, right? And this notebook is going to pick up the seller ID and create a husky in PySpark, and we can do that by using PySpark. So df.withColumn husky, that's the new column name, cha2, that would be the algorithm, the library that we can actually use to house the column that we passed as a parameter using MD256. Okay, that's fine. And then we are going to write the data frame in Delta format in our data lake, right in this directory, test3 in this container, test3 underscore sellers. That's great. Of course, we have to import the PySpark libraries here. We can do that by using from PySpark.sql.functions import these two functions. We don't actually use the concat. And now if we run, actually we don't need to run this. We will run it all together when it's done, because we have one more step, and that would be to add one more notebook here. And if the second step is successful, then we move to the third one, and we are going to create a new notebook, ACL create. Here, back in this notebook, let me comment this out, because if we are going to run it again, then it's going to give an error, because we have already created the mount points. So if we try to create those mount points again, it's going to fail, and we don't want to do that. By the way, if you want to remove the mount points, you can use this command here, dbutils.fs.unmount, and here you provide the mount point path, right? Now, in the next notebook, what we are going to do, we are going to use SQL, pure and simple SQL. That's right. And we are going, let me copy the command I have here. Come on. And sorry for the delay. And here we have our SQL. So we create or replace view temp example seller as we select from our container in the Delta Lake. You see here we have the path specified, the mount point for pointing to test3 container / sellers, which is the directory. This is where we save the data in the previous step. Remember, here we save the data here in the data lake in Delta format. So although we read the data in ParkKey format, then we can specify the format we want to save the data now, and we chose the Delta format. Let me pause for a second and let me say something about ParkKey and Delta format files. ParkKey files are not row-based like the CSV files or the JSON files, but it's column-based, so it's quite fast to work with, especially if you only need specific columns, like a subset of columns. ParkKey files are ideal for fast reads, and the file sizes are quite small compared to CSV. Sparky also has metadata which describes the schema and the structure of the file, so you have the data types. Unfortunately, in order to see the content of Sparky files, you have to write some code. Now, Delta is Sparky for Sparky files with an additional layer over it with advanced features like supporting ACID transactions, time travel, concurrency, concurrency control, transactions logs, so you can keep history and flexibility in terms of performing update, delete, and merge actions. So between using JSON, it's better. Sometimes, not all the time, it's better to use Sparky files and Delta. Delta is the most popular format, I would say, on Azure. You can do a lot of things. I quite like it myself. So we transform the Sparky data into Delta for the Sparky format into Delta format, and we save the data in the data lake. And in another notebook now, we create a temporary view in the Hive meta store, how it's called, and we select from. Actually, let me see how it's called. You click here on the menu, you click data, and you have this Hive meta store, right? And I have already created these tables here. Let me drop these tables, delete, confirm, and delete this one too, right? So here we are going to create a table in the Hive metastore, and we are going to get those data into Power BI, into desktop Power BI. Here this is just a simple query. It doesn't mean anything. You can write, but I'm going to show you that you can write SQL to query Delta data, which is quite cool if you don't want to use PySpark. And for me, that I'm coming from an ETL background, when I have complex queries, I don't use PySpark. I don't like PySpark for complex joins and transformations. I know it's different if you are coming from a Java background or something, you prefer PySpark, but for me as an ETL engineer, I prefer SQL for this type for complex queries. Anyway, we create a table here in the Hive metastore using this SQL command. Pretty simple, right? Be careful, you have to click here on SQL, because by default it's usually Python. So click here on SQL and that would be fine. It's going to provide you this magic command here, SQL. Right, and now back into the data factory, and here we have to specify the link service, Azure Databricks. Okay, that's fine. We test the connection, it should be fine. This is just the connection between Data Factory and Databricks. And under settings, we have to provide the path to the notebook, users, ACL, right? No base parameters, just that. And we are good to go. Publish. Here we are. We have to publish. It's like before we run it. Now, if we run it, let's see how if it succeeds or fails. Let's see. Now we are running the first step, which is copy data from our one directory, from our data lake, from one container to another. You click here on refresh notebook. You can see now the second step is running. You can see this blue circle here, loading, in progress, right? And you can also, what is cool about that is you can click on the glasses and it shows you the notebook URL. like this is the instance, and here you can see what it actually executed, right? The commands that it executed, and you cannot change anything here. You can see what it actually ran, which is quite cool, quite nifty, I would say, and quite very useful. And you see the command took 0.07 seconds, and you can see it ran those commands successfully. If there is a failure, the status could be here like failed or something like that, and you could be able to debug the code and see exactly what the error was. So that's why I prefer Databricks than using Data Factory to perform simple calculations. For example, here it failed. So let's go back and execution. Here you can see it failed. Now it provides you the link. Copy the link, paste it here. Let's see. Created date cannot be resolved. Yeah, I think I changed that to create DT, not date. So that was my mistake. Let's go back to here. As I said, you cannot change this is just a snapshot of the code that our Data Factory run, right? So you can see it says failed, but it was a good example how it works. If it fails, it provides you can see the error here, right? You go back, you fix the error, and then let's do it at seller 2 in case it has already created the shouldn't actually back to data default, but it already did that, right? So let's create seller 2 for this example and rerun Data Factory, and in this case it should run fine. Debug again, it's starting again, it is running the first step. As you can see, even for the first step it's like 10 record or something. It took 12 seconds. It's actually very slow. So moving data around using Data Factory and performing transformations is not the best. Actually, for me, it's quite irritating. That's why I think it's a good orchestration rule. It failed again. Okay, that's not the best day, actually. So let's see. Override true. Yeah, already exists in test. Actually, you can mode override. Okay, here we can specify the mode override. In theory, now it should run, right? It's going to override the existing data. Now the existing data was there, so it failed. Back to Data Factory, we run it again. I apologize for the mistakes, but it's actually a good example to see how you debug the code, even in a very simple, pipeline, right? Let's go. Hopefully, it's going to run successfully. Come on. It's running. Oh, 19 seconds finally. Now it started step 3, which is to create the temporary view. And in progress. Man, that's so annoying. It takes centuries for one small thing, right? And it succeeded. So if we go back to Databricks and you click on data, under Hive Metastore default, you will see temp example seller 2, which is our new table here. It contains all this data. With the created date this is the additional column that we added in Data Factory here in the step 1. As you can see, we added under source, we added one additional column. You can add multiple additional columns. It's pretty useful if you want, static something like that, or static data, or to add dates, etc., etc. And then we wait a minute. Yeah, and then we created the hash column, the hash key here, based on seller ID. Perfect. Now we added 2 columns. The next step would be to download this data here from Power BI desktop. This is Power BI now. This is what you see. Close that. Click on Get Data on the corner, and upper left corner actually, click More. And here we are going to click Azure and Azure Databricks. Click Connect, and on server host go to Databricks, Compute, click on the cluster name, scroll down to Advanced Options, and JDBC ODBC server hostname, copy that, paste it here, the same for HTTP path, and paste it here, click OK. You are going to need an access token. I have already done it, but on the same way I created an access token before, create an access token for Power BI and paste it here, and it's going to and you're going to have access to Hive Metastore on Databricks, and you can see here it provides us all this Hive Metastore data under default. Click on the table you want to download and click load, and you're going to download the data from Databricks environment into Power BI desktop, and then you click on data and you will see the data here, right? Perfect. So this is a full, almost like a complete data pipeline, a very simple one apparently, but this is the concept. We load the data usually somewhere from the cloud or from our on-prem environment, and then using Data Factory we perform a few transformations. Usually we call the notebooks, the Databricks notebooks, that contain all the code for the transformations, and we add new extra steps on Data Factory for additional columns, or to say that this data pipeline completed successfully and this kind of stuff. But it's a good orchestration tool, not a so good ETL tool. That's my opinion, at least. I hope you enjoyed the video. If you like the video, click the like button and subscribe to the channel, and I will see you in the next one.